Hello, driving intelligence community. I have an interesting topic for this video, and no, it's not once again about my 10th generation F-150. This video is about my neighbor's F-100. This truck has been somewhat restored, looks awesome, and sounds amazing with a 351 engine. It was handed down to my neighbor when his grandfather passed away, and he asked me to take care of a few troublesome issues. Before moving on, I need to apologize for the sound quality of this video. I'm not at home where I produce most of my videos because my father is in the hospital and I'm in North Carolina helping my parents. But I felt it important to produce videos with some material I have on my laptop. Thanks in advance for your understanding. The first corrective action I'm going to take with this F100 is fixing the choke problem. I often hear him goosing this engine to keep it running in the mornings because the choke isn't activating as it should. And to eliminate some frustration when taking off this air cleaner, I'm going to shorten this stud. This F100's got a 4-barrel Holley and it's equipped with an electric choke. The first thing I'm doing is just checking the wiring out, and you can see that the wire is attached to ground properly, but when I follow the hot lead of the electric choke back, it's connected to the battery side of the starter solenoid, which means that it's always getting juice even when the engine's not running. Now what does that mean? It means that the choke is opening up the valve before start, even when it's cold. What it's supposed to do is start when the key is put in the run position, and this choke will be partially closed, and as that bimetallic spring gets hot in there, this thing will slowly open up as the engine warms up. To provide a better visualization of choke operation and adjustment, I snagged this image. The electric choke is already attached to ground and must be connected to a switched 12-volt source that is hot at all times when the key is in the run position. With the engine cold, I depress the gas pedal to the floor to put the carb on the fast idle cam, then slightly loosen the 3 adjustment screws and rotate the choke cap until I have about a 1/8 inch opening in the throttle blade. At this point, I start the engine and quickly make micro adjustments while the engine is still cold to achieve best cold idle operation. Once I'm happy with idle performance, I make sure all choke adjustment screws are tightened. I've properly wired the choke now. I've got this hot to a switch circuit. It's only going to come on when I turn on the key. And I've also adjusted the choke to give me a little bit of an opening here. It's a little bit too big. You want this pretty much closed to pull more fuel than air into the carburetor and into the engine when you're first starting it up and when the engine's cold. And then as it heats up, this butterfly is just going to slowly open up. Let's see how it starts. Okay, I've primed the gas pedal 3 times just to prime the engine. Hear me over this monster. You can see that the butterfly is completely open. That means that the electric choke is working properly. It slowly opened up. I goosed it down to drop it off the fast idle cam, and it's got a little bit of vibration. I don't know if there's a cam in this engine, but it's running good. I need to check the RPM now to make sure it's idling properly, but the F100 doesn't have a tach, so I'm going to use this old Sun Pro that I haven't used in years. You can see that it gives me RPM at various cylinder counts, so let's check the RPMs. So it looks like it's running a little fast and the idle's jumping around. I dropped the idle. Sounded pretty good, smoothing out. The idle is down about 700 RPM. Again, it's just jumping around a little bit, but I'm not sure what this idle should be set at, but I'm going to make sure that it's enough to power the alternator, which will give me plenty of juice if they're running all of their accessories like lights, the fan. Not much on this engine to run. Over 16 volts is not good. It should be around 14, so I got to figure out what's going on with this alternator. So we've definitely got a voltage regulator problem. When I turned everything off, this thing is getting 17 volts. It's going to destroy this battery. And there is the voltage regulator, so I need to pull it out, check the numbers, and get a new one. Went to Amazon and quickly got the new voltage regulator, so I'm going to go ahead and hook this up and retest the voltage. Again, it's pretty simple, plug and play. Here are the 2 voltage regulators put together. You can see that the spacing of the pins, well, let me turn it over so you can see, is the same. And if you look at the inscription on each, which I wanted to make sure of before I connected it, it gives you indication of what connection it's supposed to be. And it's identical on both, so I feel safe hooking this up. Okay, so we're hooked up, ground is reconnected, battery is fully charged, quite a bit of power. Let's start it up and try it out. Alright, so the engine's running. Let's check the voltage, and it's exactly what it should be, 13.45 volts versus the almost 17 or maybe more than 17 it was at. Now this F100 runs and sounds awesome. Hope you enjoyed this video. If you did, please give me that thumbs up. Please subscribe, and I'll see you next time on Driving Intelligence.